Anyone have 1x yet?
Yeah.
What is it like?
9.66.
9.7 units. Okay. Anyone have 1y?
2.59,
Okay.
so 2.6.
0.6. Anyone have 2x? Okay.
1.04.
And 2y? Listen.
5.91.
5.9.
Yeah.
And anyone have 3x? Aaron again?
How about negative? Is that right?
Absolutely.
Okay, negative 4.7.
Okay. Anyone have 3y? No?
Negative 1.7.
Negative 4.7? So your question, I got negative, is that right? Well, let's take a look at the vector. What coordinate is it in? Or what quadrant is it in? 3, which has a negative x and a negative y. So yeah, it looks good. Okay, so if you wanted to break these guys back, if you wanted to put them back into their normal vector states, you would use an inverse tangent to get their angle, and you'd use the Pythagorean theorem to get their magnitude, which you could do. So if you put in 9.7 squared, 2.6 squared, square rooted that, you would hopefully get a magnitude of 10. And if you said the inverse tangent, in fact, give this a try. So go tangent negative 1 of the y value of 2.6 and the x value of 9.7. And see what it gives you for an angle. Okay, make sure you are in the degrees. You already have it? Okay. Let's take a look. I thought I fixed all these guys. Oh, it's your radians. Okay. This is the problem with fixing them all at once, is I forgot how to do it. Here, use this one. I fixed them all last year, put them all in degrees, but I have since forgotten how to do it. Well, one of them actually wrote down, I put a little, like, a note on them, so I'll fix that later.
Just click the reset button.
That might work. I'll do it later. So what angle did you get?
15.
15?
It worked.
It works! Yay! Okay, now try this. Take the square root of 9.7 squared plus 2.6 squared. It's 10? Hey! Math still works. Okay, 10. Okay, now that you understand that, this is critical. Take the inverse tangent of your negative 1.7 over your negative 4.7. Something interesting is going to happen.
Doesn't not work so.
You're like, hey, it doesn't give me what I wanted. Okay, so it makes sense to height. Does it make sense? So besides, does it make sense to the rest of you? What number did you get? 20. Not 200. Because your calculator is dumb. Your calculator doesn't know, because it's basically doing the math inside the parentheses, your calculator doesn't know if this is a positive value or two negative values. Doesn't know. All it sees is 1.7 divided by 4.7. So it gives you an answer. It doesn't know that it's 200 degrees, or 200. So if you do an inverse tangent, you need to know, because you're smart, whether the vector is in component 2 or component 4. Or if it's component 1 or component 3. Because if you put a negative and a positive in here, then all it's going to see is a negative number. It doesn't know which numerator or denominator is negative. Does that make sense? So if you try to do tangent negative 1 of 3 over negative 2, it doesn't know, because that's going to be exactly the same as the inverse tangent of negative 2 over 3. Okay. It doesn't know which one's negative. You need to know that. You understand? Okay. When you express angles, you really should express them to the entire 360-degree circle. So if you got one at 200 degrees, which is right there, no, right down there, 200 degrees, it's going to be like 20 degrees. Wait a minute, 20 degrees is like here. So this is 20 degrees.
Oh.
This is 200 degrees. Okay. The calculator doesn't know. It's going to say it's this value. So you're like, oh, 20 degrees. Wait a minute. You need to know that the vectors, the two components of the vector were both negative. It's not 20 degrees. It's 180 plus 20 degrees. Make sense?
Yes.
Okay.
So,
Yes.
when, that makes sense. Why are we doing inverse tangent? To find what?
Inverse tangent allows you to find the angle. Let me show you what I mean. Run out of space. Okay, I'll just squish it in here. So you know that tangent of an angle is the opposite over the adjacent?
Yeah.
Okay. If inverse tangent is basically putting the tangent on the other side.
Adjacent or opposite?
No, it's still opposite over adjacent. But when you do inverse tangent, you are untangenting it itself. You are untangenting it. So if you take the tangent of an angle, you get two values. If you take the inverse tangent of those two values, you return the angle. So you use an inverse trig function to get an angle, and you use a trig function of an angle to get a value. Does that make sense? So basically, the inverse tangent of opposite over adjacent returns the angle. We take a trig function of an angle and we get legs. We take an inverse trig function of legs to get the angle. Does that make sense? All right, so let's add our vectors together. Go ahead and turn the light off so you can. This is what I'd like you to do. Okay, so there's a bunch of. This is basically what I just told you. To add their components together, use the Pythagorean theorem. Oh, sorry, I haven't told you this. So this is what you need to do. These are the rules. To find the components of a vector, to find the resultant of two vectors, you add their components together. Okay? To find the resultant of two vectors, you add their components together. We're going to do 1 and 2 today, and hopefully 2 and 3 or 1 and 3 later. Probably 1 and 3 tomorrow. So this is what you do. We're going to add component 1 to component 2. Add 1x to 2x. Add 1y to 2y. That will give you their summed components. Once you have their summed components, use the Pythagorean theorem to find their magnitude and the inverse tangent to find the resulting angle. And hopefully, it's going to look something like this. Hopefully the result will be something like that. That's going to be the result. This is vector 2, this is vector 1. Okay. So do that now. I'm going to be a couple minutes behind you on the whiteboard. So add 1x to 2x, add 1y to 2y. Those are the summed components. Do the Pythagorean theorem with the summed components. That will give you the resultant magnitude, and use the inverse tangent of the summed components. That will give you the angle. If you're not sure yet, watch me. I'll do it on the back. I'll do it on the whiteboard. Question?
We're adding 1 and 2.
You're adding 1x to 2x, and then 1y to 2y.
What about
The third vector we will play with tomorrow. We're going to run out of time because there's only about 8 minutes left in class. So we're going to run out of time for the third vector. We'll play with that tomorrow and then talk about vector subtraction. 1x and 2x and 1y and 2y. putting some pencils down. When you have your resultant magnitude and your resultant angle, see if it kind of jives with the qualitative vector addition. What you're doing right now is quantitative with numbers vector addition. The qualitative vector addition is what we do when we add them head to tail. So see if it looks like something like this. Imagine slapping this guy on a coordinate plane where that's the magnitude and that's the angle. See if it jives with your imaginary head-to-head or head-to-tail vector. Oh, cool. Look, our light's broken. Nice. Less light on the whiteboard. Maybe if I just turn the lights on and off, then it's like you can kill all the whole front row. Okay, so those of you who use the Pythagorean theorem, what did you get for the resultant magnitude? 14.67? 13. So 13.7. I'll just go ahead and use 3.7. Is that about right?
Yeah.
Okay. And those who use the inverse tangent, what did you get for the angle?
38.4.
38.4? So does 38.4 degrees and 13.7 in magnitude pretty much match what we have in our qualitative imagination? Okay. That's how you do quantitative vector addition. You break the vectors into their components. You add the components together, x and x and y, and then you use the resultant x under the resultant y. Oh. The inverse tangent of the resultant x under the resultant y gives you the angle. And the Pythagorean theorem gives you the magnitude. Now you can do this with 30 vectors or 40 vectors. This is what computers do. They take lots and lots of vectors and they squish them all together. They're like, okay, the baseball is traveling this fast, there's this much wind. The airplane is traveling this fast, there's this much wind. There's more people on this side of the airplane than there's on this side of the airplane. Okay. Let's stop here and call it a day.